In this video, I want to explain the application I have developed for using e-paper with KAIStack evaluation board. The application is a combination of different operations, and each operation composed of several sections. At the end of each section, the application waits for an interrupt, except the orange ones. After finishing orange section like section 1 and section 3 in display operation or clear operation, the application goes immediately to the next section because they don't need interrupt. Also, section 1 of display operation is considered for developers to design customizable drawing or make menus. So section 1 is available for developer in EPT for in 37G KAIStack application.c. This is section 1. There are two kinds of state machines. An state machine is for controlling the whole application and determines which operation must be run. A developer can modify this state machine based on their requirements. This state machine is available in state machine application.h and .c file. Another state machine are for controlling the components of application and determine which section must be run. These state machines are usually the same for different scenarios. These state machines are available in state machine components.h and c files. Using separated state machines prevent the code from sparse matrix and eases editing and upgrading the state machines too. The application state machine is a place where we can define our display scenarios for our application. First, application perform initialization, and after the initialization is done, it will start reset operation and stays in reset state until the reset operation is done. Then it will start an operation to clear e-paper and stays in clear state until the clear operation is done. By finishing a clear operation, application will start an operation to display an image on e-paper and stays in display state until the display operation is completed. By finishing display operation, application will go to normal state and does its routine jobs in app main function. When a value is received from KNX network for communication object, application will start an operation to display the received value on ePaper and stays in display state until the display operation is completed. By finishing display operation, application will go back to normal state again. Application state machine is available in state machine application.h file. Since each operation composed of several sections, start an operation means call first section of the operation. For example, a start reset means calling section 1 of reset operation, or a start display means calling section 1 of display operation. But don't forget that for display or clear operation, section 2 is called immediately after section 1 because section 1 is just a calculation and doesn't need to wait for any interrupt. In the last section of an operation, phase down flag is set to indicate the termination of the operation. By calling app ePaper main files function, phase down flag is reset and the next operation will start. Calling start operation are available in app ePaper main phase function from state machine application.c file. Calling application state machine will happen in app main function when an operation is done to start the next operation, or when a value received from KNX network for communication object to display the received value on ePaper. Calling component state machine will happen when a hardware interrupt such as a timer, SPR, or EXTI triggers. When timer 1 is expired, main state machine will be called from app main function. When XTI interrupt for busy line of ePaper triggers, main state machine will be called from XTI handler. And when SPI interrupt for transmitting data to ePaper triggers, main state machine will be called from SPI handler. These handlers have been defined in hello epaper.c file. And you may ask what the job of main state machine is. Main state machine calls the proper component state machine according to the active operation or main phase. If application is running reset operation, then reset state machine will be called. Or if application is running display operation, then display state machine will be called, and so on. Please note that normal state is kind of idle state and is not a real operation, which means there is no any section for it. So there is not a normal state machine here. Any state machine and the state machines for different operations are available in state machine components.h and c file. Reset state machine resets the ePaper. For this, it makes RST pin high for 20 milliseconds, then low for 2 milliseconds, and finally high for another 20 milliseconds. So it sets timer with proper value of millisecond and wait for timeout to perform another section. First, it makes RST pin high, goes to in its RSTH1 state and sets timer 1 with 20 milliseconds. When timer 1 is timeout, it will make RST pin low. Go to RSTL state and set timer 1 with 2 milliseconds. When timer 1 is expired, it will make RST pin high again and go to RSTH2 state and set timer 1 with 20 milliseconds. When timer 1 is expired, it will perform some jobs to finalize the operation. In displaying or clearing operation, section 1 performs calculation to create an image. By finishing calculation, section 2, which doesn't need wait for an interrupt, will be run immediately and power on the ePaper. Then wait for interrupt from busy pin. Triggering this interrupt, call section 3.1 to transmit send image command to ePaper. And immediately after that, the bytes of image are transmitted to ePaper in section 3.2. By transmitting the last byte of image, send all success signal will be emerged, and emerging this signal calls section 4 to refresh the display of ePaper. Then wait for interrupt from busy pin. Triggering this interrupt calls section 5 to power off the ePaper, and then again waits for interrupt from busy pin. Triggering the interrupt calls section 6 to release memory of image and sets timer 1 for 2 seconds. Then waits for timeout. By expiring timer 1, section 7 is called to finalize display operation. What I described in the last slide is indicated in display state machine here. Please note that display operation is similar to um, clear operation, but their data is different. Display sends image, but clear sends color. And also done and send all success are not events, but flags in the application. Uh, A customized driver can be made based on the configuration in KaiConfig.h, which determines the KAIStack board and the modules. KAIStack board library are located in this folder. Target STM32, KAIStack system, target ST, STM common evaluation board, STM common evaluation board. And in case a developer can use LL libraries and drivers located in Kai system target STM32 lib. For example, the specification of board we use in this project is STM32F103R Red 6 and module is KNX TP. So KAIStack evaluation board library is KAIStack eval STM32F10XRX R10cube.h. F1, this one, KAIStack evaluation STM. And LL libraries F1 driver. For example, we can find spray.c here. Based on above files, I have developed my customized driver, ePaper drv.h and .c driver. And last question, where should a developer start from? EPD for in37G KAIStack application.c file contains the section 1 of display or clear operation, which allows the developer to design their drawing for ePaper. Section 1. And a state machine application.h and c Files contain application state machine, and the developer could change the sequence of operation by editing this state machine. Thank you.